back. I'm Professor Steele, and today we are going to look at another one of our laws that relates to our triangles. Not a right triangle, but our oblique triangles. Recall that an oblique triangle has angles that are between 0 and 90 degrees. And we have labeled this one A, B, C, which means that our corresponding sides are side A, side B, and side C. So what we're going to do is drop a perpendicular to create two right-angled triangles. In these two right-angled triangles, we'll note that if I focus on angle B, sine of angle B is this height divided by the hypotenuse. If I focus on this triangle, we'll notice that sine of angle C is this height, the opposite side to that angle, divided by B. So there's two relationships we have right there. If I just look at these two relationships, you'll notice from the first line, we can rewrite H to equal C sine B. And from the second line, H equals B sine C. So we can set these two equal to each other. So we have C sine of angle B is equal to B sine of angle C. Now we can take this equation, this relationship, and in two steps we can divide by C, which would give us sine B equals B sine C divided by C. And then we can divide by B. So our final setup is sine of B divided by side C equals sine of C divided by side C. Similarly, if we dropped a different perpendicular, for example, now we can look at angle A and angle C and compare them. So angle A, sine of A, again, let's call this K now, is equal to K over C, which is the hypotenuse, and sine of C, angle C, is K over side A. Similar to before, we can simplify and find both of these in terms of K, and just like before, we can set them equal to each other. Using the same logic that we did in the previous setup, we'll notice that sine A divided by A equals sine C divided by C. Since sine C divided by C is equal to sine B divided by B, these are all equal. So sine A divided by A equals sine B divided by side B, which is equal to sine C divided by C. And that is the development of the law of sines. Thanks for watching. Please like and subscribe to EdVantage.